Hello, grade 12s. Welcome back to the channel. In today's lesson, we're going to be looking at financial maths, future value, and then by the end of the lesson, you should be able to calculate the future value of an investment and also be able to calculate the regular installment of an investment. Right, so without any further ado, let's get right to it. Okay, so to start off with the lesson, let's look at the future value formula. So there we have it. And then to break it down, our FV, that's the future value. And then what is the future value? This is basically the money accumulated after the investment period. And then we have X. These are our regular installments or deposits. And then we have I. This has to be our interest rate. And then note that our interest rate will be R over 100. So you'll be given this interest rate in a form of a percentage, but then you have to convert it to a decimal by dividing by 100. Then we have N. This will be the number of installments or deposits made. Or sometimes it can represent the number of, not the number of, or the investment period, meant to say. It can represent the period. So how long was the investment for? Right. Then regular installments, let's come back to this. Your regular installments, I call them regular installments because it will depend on your compounding period. So if they're monthly, that means X here represents the amount that will be deposited regularly on a monthly basis. And then if it's quarterly, also represents the regular installments that will be made on a quarterly basis. If it's semi-annually, represents that amount that will be made regularly on a semi-annually basis. So, okay, let's look at a couple of examples to help us better understand how to use this formula there. Okay, so we have an extract from the exam, 7.2, says a businesswoman deposited 9,000 into an account at the end of January 2014. She continued to make monthly deposits of 9,000. So this 9,000, we now understand that it becomes our monthly installment, right? At the end of each month, up to the end of December 2018, the account earned interest at a rate of 7.5% compounded monthly. So let's pay attention to our compounding period there. 7.2.1 says calculate how much money was in the account immediately after the 60 deposits. So we are being told that the number of deposits that are made are 60. And then even if you were to check from 2014 all the way to 2018, that's exactly 5 years. So 2014, 2015, 2016, then 2017, and 2018, that's 5 years. And then how many months are in 5 years? It's 60 months. So if there's 60 months, that means 60 monthly deposits have been made. So to start with our future value formula, there we go. And then it's just a matter of substituting all that we've been given into the formula. So the X is 9,000. And then we have 1 plus the interest 7.5, but then remember it's 7.5 over 100, which now we're going to have 0.075. And then 0.075 over the compounding period. So it's monthly, we have to say over 12, right? And then N, 60, the number of deposits made, then over 0.075 over 12, right? So always remember to divide by the compounding period. Then, if you punch all of that into your calculator now, simply just grab your calculator, and then we get 652,743.95, rounded off to 2 decimal places. Remember, as the instruction of the exam, round off to 2 decimal places. Okay, let's proceed and look at another example so that we better understand this concept here. Okay, so another extract from the exam, it says on 31 January 2022, Tino deposited 1,000 into an account that paid interest at 7.5% again, and then per annum compounded monthly. He continued depositing 1,000 on the last day of every month. So now the 1,000, we understand that it becomes the regular monthly installment. He will make the last deposit on 31 December 2022, started 31 January 2022, ends 31 December 2022. Now we can all agree that this is exactly 12 months. This is a whole year, right? Then will Tino have sufficient funds in the account on 1 January 2023 to buy a computer that cost 13,000? Justify your answer by means of an appropriate calculation. So again, our future value formula. There we go. So make sure that you start with the formula. Then X is 1,000. And then we have 1 plus our interest 0.075 divided by the compounding period monthly. So it's 12. And then N has to be 12, right? Because there will be 12 monthly deposits that are made between 31 January to 31 December, if of course it doesn't miss any payment, which we are not told. Then over 0.075 over 12. Now at this point, you have to punch all that into your calculator. We get is 12,421.22. Now remember, we must make a conclusion. Will he have sufficient funds to buy the computer here? Obviously not. So no. Tino will not have sufficient funds. Tino will not have sufficient funds. Obviously, we can see why, because the money that it accumulates over the investment for 12 months is less than the cost of the computer. So which is 13,000. Okay, let's look at yet another example. Point 2, it says, Mr. Duda decided to save money towards his son's tertiary education as follows. Point 1, he paid 600 per month into an account that paid 8.7% interest per annum compounded monthly. Point 2, his first payment was at the end of January, in which his son started grade 1, and the last payment at the end of December when his son completed his grade 12. His son did not repeat any grade. Then point 3, he withdrew all his savings 1 month after his last payment. Right, note this statement here, very important. Then calculate the amount that was in his account by the time Mr. Duda withdrew all the savings. So again, we're going to start with our future value formula, because this is savings. So we're trying to grow this money into a certain future value, right? So this is an appreciation annuity. Then X is 600. We have 1 plus the interest 8.7. So 8.7 over 100. is 0.087 over 12, and then to the exponent of, so from grade 1 to grade 12, that's exactly 12 years. But then remember, our n here should be in terms of months because this is compounded monthly. So that's 12 multiplied by 12. And then we find that there are 144 months in 12 years. So we substitute 144. So that means there will be 144 monthly deposits of the 600 that are made throughout the investment. So 0.087 over 12. Then at this point, you know what to do. Grab your calculator and simply punch all of that exactly as it appears. And then we have our amount is 151,438.2008. But then you will notice that I'm not even rounding it up because that's not the final solution that we have. Remember, they said he withdrew all his savings 1 month after his last payment. So that means he left this money here to stay in the savings account for an extra month. But then remember, in that month, he was not making any deposit, right? So he just left the money there. Now, when the money is left into the savings account, it obviously grows interest because remember, this is an investment account. So if you leave your money in an investment account, it should accumulate interest. So how are we going to grow this money here? We want to use our compound formula, right? So note, in order to grow the money, we use compound formula. Remember, this is the formula that we use in order to grow a lump sum, right? So this is a lump sum of money. And then now it will be grown with the same interest rate, 0.087, and then over 12. But then for a period of how many months? Only 1 month, right? And then all you have to do now is further punch this into your calculator. And then at that certain time, his future value will now have grown to 152,536.13. Now, if we round off to 2 decimal places. Okay, so now I hope you understand how we use that statement to answer our question here. So after you have found your future value, remember to grow it for that month in which he was not making any deposit, but simply just left the money in the bank or in the account. Okay, so let's continue now. I think we are done with having to understand how to use the future value. And then we have completed the first objective of this lesson, which is knowing the future value formula and knowing how to use it in order to calculate the future value amount. Let's now proceed to objective number 2 of the lesson. So objective number 2 would have to be knowing how to calculate, so calculating the regular installments. So the regular installments, those are your X payments, right? So we already know the future value formula, X and then bracket 1 plus I to the exponent of n minus 1, and then all over I. Now we want to come up with a formula that will make it easy for us to find our regular installments here, X. Now we're just going to manipulate this formula and make X the subject of the formula. So provided that you wanted to make X the subject of the formula, we do understand that the first thing that you would have to do is take the future value, multiply it by the interest, and then this side you still have that. And then now at this point, because I want X to be the subject of the formula, I can just swap this formula here and then take this over to this side. So remember, I'm not transposing, I'm simply swapping the positions, right? So no signs will change. Then future value multiplied by the interest. Now remember, I want X to be isolated on the left-hand side. So what do? divide both sides by this. And then what I do on the left-hand side, I also have to do on the right-hand side. It's the rule of maths. Now at this point, I do understand that this here will divide out with that. So the x will be future value multiplied by the interest all over that. That means the formula that we will use to calculate the monthly installments for the future value is this, or the regular installments is that. Now note that, save it on your notebook. Okay, so now let's look at a couple of examples that will assist us in having to understand how to use this formula here. Okay, we have 6.4. It says Sarah is 18 years old and wishes to accumulate 10 million by the month before her 50th birthday. She will deposit equal monthly payments into an account that pays 15% per annum compounded monthly. The first payment starts on her 18th birthday and the last payment 1 month before her 50th birthday in order to make a complete year. Then calculate the monthly installment that Sarah will make, right? So understand this. We are given the interest 15%. And then note that here we are given the future value, and what we are trying to calculate are the monthly installment. So we are trying to find X, right? Then, okay, this is from 18 years all the way until she's 50 years. So we want to understand how many years are in between here. So if we say 50 minus 18, so we're just going to say 50 minus 18, and then we get 32 years. Now, how many months are in 32 years? We just multiply that by 12. Then multiply that by 12. We now understand that there are 384 monthly deposits that will be made, right? So for 384 months, 384 monthly deposits made if she doesn't skip any deposits, right? So again, we start with the original formula, future value. So it is very important that you always start with the original formula. Then from then on, you can manipulate. So our manipulated formula is now future value and then multiplied by the interest. And then we have all of this down here. So the benefit of just using this formula is that you don't get to round off any values, and then that allows for precise answers, right? So you don't have to go through the hassle of rounding off answers and saving them into your calculator. You're just going to simply substitute and punch everything into your calculator. Then you get your answer like that. PDA effective and efficient. Then 10 million. How do we write a million? 6 zeros. Then multiply that by the interest is 15%. That's 0.15 over 12 because it's compounded monthly. And then over, we have 1 plus 0.15 over 12. The number of payments, 384, then minus 1. At this point, all you do is just punch all of this into your calculator, then you get your value. And then the monthly installment that we get from punching that into our calculator, it's 1,068.85 rounded off to 2 decimal places. So these are the monthly installments that you would have to make for 384 months in order to accumulate that amount in a 50th birthday, right? So let's look at yet another example so that we better understand the use of this formula. So you will see how simple it makes things to be. Okay, so 8.3 says Thabo wanted to save 450,000. That's our future value amount. That's the money Thabo hopes to accumulate in the future after the investment period. as a deposit to buy a house on 30 June 2018. He deposited a fixed amount of money at the end of every month into an account, earning interest of 8.35% per annum, compounded monthly. His first deposit was made on 31 July 2013 and his 6th-year deposit on 30 June 2018. Calculate the amount he deposited monthly. So again, original formula. And then manipulated formula. So, right, at this point, we just want to substitute into the formula. So our future value, 450,000, then multiply that by the interest, 8.35. So that's 8.35 over 100 is 0.0835. So 0.0835 over 12, and then all over bracket 1 plus 0.0835 over 12. And then how many deposits were made? We are told 60. So we want to have our 60 there, then minus 1. Then all we have to do now is simply just punch all of that into our calculator. And then we find that our monthly deposits or installments will have to be 6,068.69, rounded off to 2 decimal places, as per instruction of the exam. Right. And then let's look at the last example to solidify what we have learned. Now we have another extract from the exam. Says Kuda will buy a laptop that cost 20,000. In order to cover the cost price, he made his first monthly deposit into a savings account on 28 February 2019. He will make his 60th monthly deposit on 31 January 2024. So now we are being told that there's 60 payments in between 21 Feb to 31 Jan. The savings account pays interest at 8.7% per annum, compounded monthly. Calculate Kuda's monthly deposit into this account. So again, future value, X original formula, and then like that, over I. And then manipulated formula, future value, and then over bracket 1 plus I to the exponent of n minus 1. Right. Then let's substitute into the formula now. Our future value, 20,000. Our interest, 8.7. So that's 8.7 over 100, which will give us 0.087. So 0.087 over 12, compounded monthly, right? Then we have 1 plus 0.087 over 12, then to the exponent of 60. Now, from all these questions, you get that the n, you might have to calculate it yourself in some other questions, but then in some other questions, you will be given, right? So you must be able to maneuver in both situations. If you need to calculate it yourself, they will give you in terms of years, and then you just have to multiply by 12 if it's monthly, and then find the number of months. So at that point, you just simply punch everything into your calculator. Then, all right, we find that your monthly deposits or Kuda's monthly deposits will have to be 267.26, rounded off to 2 decimal places. And that's how you go about tackling these questions. So we have completed both objectives of the lesson. Now I'm pretty sure that you understand how to use the future value formula in order to calculate the future value or the amount that will be accumulated after the investment period. And then number two, you are able to still use the future value formula to calculate the regular installments that will be made into an investment or savings account, right? So that's how you tackle this type of questions. And then we're still going to continue with more complex question. But then for today, let's just end our lesson here. See you next time. Ciao.